The 4.3, the quadratic relation, y equals a x minus h squared. Okay, so we already talked about the a value here. Okay, and now we're going to focus on what does this h mean if the h is inside of the brackets with the x. Okay, and then square. So when graphing an h value, this is a little bit different. You have to have this eye for detail. Okay, we use the h value as the middle number in our chart. So on your test, I'm not going to give you the x values. You're going to have to create them depending on the h value. So here's the note. The equation y equals a x minus h squared plus k. And remember, these are all of the transformations that we're going to see. We already talked about a. We already talked about k. Now h. The h, like there's a built-in negative sign into this bracket. So the h actually has the opposite sign that is actually shown. So, for example, let's start with this. Graph the relations. Okay, we're still going to start with the y equals x squared. Let's do that first. 0, 0, negative 1, 1, 1, 1. Negative 2, 4, 2, 4. And it's okay on the right-hand side that we're not going to keep going. That's fine. Negative 3, 9. Okay? And you just go like this. That's fine. Okay, so that we've done a million times. We should all have those coordinates memorized. Now, y equals x plus 4 squared. This is what we're going to have to graph. This 4 goes in the middle here. And it has the opposite sign. So instead of being 4, it's actually negative 4. So going up, we're going to go negative 5, negative 6, negative 7. Because usually we would start at, like, say, for example, the negative 7 and move forward. So we move to the right of the number line. Okay. And then negative 3 is a bigger number. Negative 2 is a bigger number. Negative 1 is a bigger number. So we go bigger. Okay. So let's go ahead and sub all of these in to y equals. We're going to have negative 7 plus 4 all squared. Then we're going to have negative 6 plus 4 all squared. Then we're going to have negative 5 plus 4 all squared. Negative 4 plus 4 all squared. Negative 3 plus 4 all squared. Negative 2 plus 4 all squared. And negative 1 plus 4 all squared. Okay, so all I did was sub in these x values to where the x is. Now, let's solve for the bracket and then square it. Remember, we have to do BEDMAS. So bracket first and then square, which is exponent. Okay, negative 7 plus 4 is negative 3. Negative 3 squared is 9. Negative 6 plus 4 is negative 2. Negative 2 squared is 4. Negative 5 plus 4 is negative 1. Squared is 1. Negative 4 plus 4 is 0. Squared is 0. Negative 3 plus 4 is negative 1. Squared is 1. Negative 2 plus 4 is 2. Squared is 4. And negative 1 plus 4 is 3. Squared is 9. So let's go ahead and graph. And remember, these are negative 7, 9. Negative 6, 4. Negative 5, 1. Negative 4, 0. Negative 3, 1. Negative 2, 4. And negative 1, 9. Okay, you don't have to write out the coordinates. You can just reference them straight in the chart, and that's okay. So negative 7, 9. Negative 6, 4. Negative 5, 1. Negative 4, 0. Negative 3, 1. Negative 2, 4. And negative 1, 9. Okay, and then we just connect this with a curve. And this is going to be our function, y equals x plus 4 squared. Okay, so before we move on, let's talk about what's going on and what we see going from the blue to the purple. So going from the blue graph, which is our original, to the purple graph, which is our transformed graph, we see that every single coordinate that we have shifted it. Oh, I'm going to apologize. This is supposed to be here. I was thinking that the scale was different. My mistake. That goes right through the cross. I was thinking the scale was by 2. Okay, so this is graphed onto these. This one's graphed onto this. This one's graphed on this. Okay, if we look at every single coordinate, that entire blue parabola is shifted to the left 4 units. Okay, so keep that in mind. Okay, example 2, graph the relations y equals x squared. Okay, so let's start with that one. 0, 0, negative 1, 1, 1, 1. Okay, and this time we can see that the scales are by 1. Okay, negative 2, 4, and 2, 4. And negative 3, 9, and 3, 9. Okay, so this is our original. And the only reason it looks more narrow is because of the scale. Okay, and the width of the grid here. Okay, so what we do is we accept the y equals x squared as the original on this grid, and then we're going to graph the other one, y equals x minus 6 squared. Okay, so this x minus 6, we want to put it into this center box here. Okay, it's going to be our center value. The h value here, it's not negative 6. Remember, there's a built-in negative sign. We're going to flip it. It is 6. Okay, so the numbers before 6 are 5, 4, 3. And the numbers after 6 are, of course, 7, 8, 9. So we have y equals 3 minus 6 squared. Okay, y equals 4 minus 6 squared. Y equals 5 minus 6 squared. 6 minus 6 squared. Okay, 7 minus 6 squared. 8 minus 6 squared. And 9 minus 6 squared. Okay, 3 minus 6 is negative 3, so negative 3 squared is 9. 4 minus 6 is negative 2, so negative 2 squared is 4. 5 minus 6 is negative 1, squared is 1. 6 minus 6 is 0, squared is 0. 7 minus 6 is 1, squared is 1. 8 minus 6 is 2, squared is 4. And 9 minus 6 is 3, squared is 9. So now I can plot 3, 9. Oh, intersection, that's cool. 4, 4, 5, 1, 6, 0, 7, 1. Okay, we see symmetry already. 8, 4, and 9, 9. Yeah, that's right. Okay, y equals x minus 6 squared. Okay, so now let's take a look at these. The original is the red, and the graph function is the green. How did we get to the green? So going from red to green, we would have had to move over to the right 6 units. Okay, every single coordinate, the entire graph, we're shifting to the right. So right, let's go 6 units. Okay, and we're going to conclude about this, this style of formula after. So when the h value is positive, in other words, it looks negative. Remember, there's a negative sign built into the bracket. Switch the sign. Okay, so when it looks negative, but it's actually positive, the graph moves to the right. And when the h is negative, but actually looks positive, the graph moves to the left h units. Okay, so it's that horizontal shift left or right. Okay, example 3, we're going to put this all together. Graph the relations y equals x squared. So let's go ahead and graph that first. 0, 0. Oh, see, the scale up the y-axis is now by 2s. So negative 1, 2, 1, or sorry, negative 1, 1, 1, 1. Negative 2, 4, 2, 4. Negative 3, 9. So kind of like in the middle there. And then 3, 9. So again, y equals x squared. Okay. Now we're going to do y equals negative x minus 2 squared plus 3. Okay, so this negative 2, again, goes into the middle. And it's not a negative 2, it's a 2. So 2, 3, 4, 5 goes down, and then we descend up. So 2, 1, 0, negative 1. Okay, so this equation is going to be a little bit more complex. It's going to be negative of negative 1 minus 2 squared plus 3. And then this one's going to be negative 0 minus 2 squared plus 3. I'll put a y for the first one. Then negative 1 minus 2 squared plus 3. And then, negative 2 minus 2 squared plus 3. Negative 3 minus 3 squared plus, 3 minus 2 squared plus 3. Negative 4 minus 2 squared plus 3. And negative 5 minus 2 squared plus 3. Okay, so now we just have to calculate these. So negative 1 minus 2 is negative 3. Okay, so essentially we have negative 3 squared. So if this is negative of negative 3 squared plus 3, what we're going to get is negative 3 squared is 9. So it's negative 9 plus 3 is negative 6. Now, 0 minus 2 is just going to be negative 2. So we're going to have negative of negative 2 squared plus 3. So negative 2 squared is 4. Like negative 4 plus 3 is negative 1. Okay, 1 minus 2 is negative 1. So we have negative 1 squared plus 3. Okay, so that cancels to a 1. So we have negative 1 plus 3, which is 2. So 2 minus 2 is 0. So we have negative of 0 squared. So that's just 0. So negative of 0 squared. That just goes away. And then plus 3 is 3. Three minus 2 is 1. We have negative of 1 squared plus 3. So 1 squared is 1. Negative 1 plus 3 is negative 2. Sorry, it's positive 2. 4 minus 2 is 2. So negative 2 squared plus 3. 2 squared is 4. Negative 4 plus 3 is negative 1. And then 5 minus 2 is 3. So we have negative 3 squared plus 3. So this is a 9. Negative 9 plus 3 is negative 6. And we can go ahead and graph this. So we have negative 1, negative 6. So negative 1, negative 6. 0, negative 1. 1, 2. And then 2, 3. 3, 2. Remember, this is symmetric, right? So this is going to also land here, right? Without even looking, but 4, negative 1. And then 5, negative 6. Okay, so y equals negative x minus 2 squared plus 3. Okay. So let's actually take a look at what's going on in this from the purple, which is the original, to the red, which is the transform graph. So we see that the purple one opens up, whereas the red one opens down. And of course, that's a result of the A value being negative, right? That -1 being there. And then now, I always like, so what I'm going to start doing is referencing just the vertex. Okay, so the vertex goes from here and move to the right 2 units and then up 3 units. Well, here we go. Right 2, up 3. And then this is a reflection. So it's a quick check. Okay, now example 4. Describe the transformations that have been applied to the following quadratic relations. So A is y equals 3, x minus 2 squared plus 1. Okay, so this is a transformation. This is a vertical stretch by a factor of 3. Okay, inside the bracket, remember it looks like a -2, but it's actually +2 is the h value. Okay, so this is right 2 units. Okay, that's that one. And then trailing behind the squared symbol is a +1. That's going to be up 1 unit. B, y equals 0.5, x plus 4 squared minus 7. So the 0.5 is a vertical compression. We say by a factor or just by 0.5. I'm okay with that terminology. Okay. The +4, because it's in the bracket, it's actually h equals -4. So this is going to the left 4 units. And then we have -7, so this is down 7 units. C, y equals 2x squared plus 8. So here's the issue with this this function. So we have y equals 2. That's fine. We know that that 2 value is our a value. So that's a vertical stretch by 2. Okay, let's talk about where did the bracket go. So we have to think to ourselves, we would have x plus or minus a number squared. Okay, we got to think, what number would have been in here that we could have simplified to just an x squared? Because when we see an equation like this, we overlook that there's actually a number in here. And that number is actually 0. Okay, because if we were to do x plus 0, like that would just cancel to x, and we'd have that x squared, which is in the original. So there's no, and I'm going to point this out, but there's no left-right shift. Okay, and then this +8 is up 8 units. So this is important not only when we state the transformations, this is also important to recognize when we have to use that h value in the middle of our chart on like a test or a quiz, or maybe if on your homework it asks you to graph something, okay, and you don't know what x values to use, it's important to recognize that when it's just an x squared, it's actually a 0.